So today the student will be able to understand the properties of equality and inequality for exponential functions in order to solve equations and inequalities. So there's two properties we need to know. The first property is the property of equality for exponential functions. And it says let b be greater than 0. So you need b to be a positive number and b not equal to 1 whole. So if b is 1 whole, this doesn't apply. You also can't have a negative b value. So we're talking about the base. So as long as b to the x power is the same as b to the y power, so as long as your bases are the same, then you can say that the exponents would be the same as well. So for example, if I have 3 to the x power is equal to 3 to the 5th power, because the base is the same number, then I can just take the exponents and say that they must be equal as well. And it works vice versa. The property of inequality is very similar. If you have that b of x is greater than b of y, well then that means that x would be greater than y. If b of x is less than b of y, then the same thing, that means that x is less than y. So for example, if I have 2 to the x is greater than 2 to the 6, then we can take the x and the 6 and just keep the greater than in between them. And it works the same direction too. So basically the idea is I can solve for my variable or my exponents as long as the bases are the same value. So if we look at this first example here, we have 3 to the x equals 9 to the 4th. Well, I can't do anything with that until I have the same base for both. So I'm going to take 9 and I'm going to turn 9 into 3 squared. So 9 is the same thing as 3 squared. It's still being raised to the 4th power, and I still have 3 to the x on the other side. But now I've created a situation where I have the same base. So because my base is 3, then I have equal bases, and that allows me to take the exponents out. But we need to simplify a little bit more first. So I have 3 to the x equals. Remember when you have an exponent on the inside and the outside of a parentheses, you're going to multiply the exponents. So our base is 3, 2 times 4 is 8. So now that the bases are the same, I can take the bases out and say that means that that exponent x has to be equal to this exponent 8. So the value of x is 8. The next one says 2 to the 5x power equals 4 to the 2x minus 1. So first I need them to have the same base. I can turn 4 into 2 because I know that 4 is the same as 2 squared. And then keep your 2x minus 1. Okay, now I have an inside exponent and an outside exponent. So I need to multiply them, but I have a binomial on the outside, 2 parts, so I'm going to distribute it. So 2 times 2x, so I have base of 2. 2 times 2x is 4x. 2 times negative 1 is minus 2. So you distribute that 2 when you multiply it across. That is equal to 2 to the 5x power. So now that my base is the same, I can take the bases out and say that the exponent, 5x, is going to equal the 4x minus 2. Okay? So then you're just going to solve what you have from there. So minus the 4x. 5x is minus 4x. It's just a single x. Minus 2, so x equals negative 2. Okay, and I forgot we were doing 2-column notes, so what I need to be doing is writing the steps out there for it too. So in this first one, our first step was to take 9 and change it to 3 squared. So because I know that I need the same base, so we did that so we could get the same base of 3, okay? Then, now that I have the same base, we set the exponents equal. Okay, the second one, the first thing I did was I needed the same base. And in this case, we knew we could change it to a base of 2. So I took the 4 and said it was really 2 squared. And then I put the other exponents back on it. And now, so step 2, we multiplied our new exponent of 2 times the 2x minus 1 that was already there. Then now that we have the same base, we set the exponents equal. And then we needed to get x by itself, so we solved the problem. All right, next, I have 4 to the x power equals 64 cubed. Well, first thing I need to do is I need the same base. And I know that I can change 64 into a base of 4. So I can say that, a base of 4. So I can say that 64 is the same thing as 4 cubed. Now, you could also change 4 and 64 to both bases of 2, and you'd end up with the same answer. So as long as you get a same base, it doesn't really matter what that base is, as long as your math is right. So I'm going to change that. So I have 4 to the x equals 64 is 4 cubed. Put the other exponent back. We're going to multiply our new exponent of 3 times our old exponent of 3 and get 9. So I have 4 to the x power is equal to 4 to the 9th. So then I can set exponents equal. So x equals 9, and there's nothing to solve because I already have the answer. All right, example 4. So first I need the same base. So right now I have a base of 3 and a base of 9. So I need the same base, and I know that I can change 9 into 3 squared. So I have 3 to the 2x equals 9 became 3 squared, and still raised to the 5x minus 4. Now I need to simplify the exponent, so I'm going to multiply 2 times 5x minus 4. That's 10x minus 8. So I have 3 to the 2x power equals 3 to the 10x minus 8 power. Now I can set my exponents equal. So I have 2x equals 10x minus 8. And now I need to solve so that I know what just x is. So I'm going to move the 10x. So 2 minus 10 is negative 8x equals negative 8. Divide by negative 8. X equals positive 1. All right, example 5. Now we're getting into our inequality instead of equality. So instead of being equal, we have a greater than symbol, but our process is still the same. The other weird thing we have here is a fraction. But my steps are still the same. I need the same base. Now, I know that 625 is 5 to the 4th power. So I know that 625 is 5 to the 4th. But the problem is, if I just do that, I still have 1 over 5 to the 4th power. Remember, in order to move a base and the exponent around a fraction, you need to change the sign of the exponent. So 1 over 5 to the 4th power, it's really the same as saying 5 to the negative 4th power. So if you have everything in a fraction at the bottom of a fraction, that's how you know you're going to have a negative exponent. So our base is 5, so I have 5, 3 minus 2x is greater than 5 to the negative 4, okay? Then we don't have anything to simplify, so I'm going to set my exponents equal to each other, but in this case, I'm going to use the inequality stated. So I'm going to set my exponents. Instead of saying equal, I'm going to still keep the greater than. So I have 3 minus 2x is greater than negative 4. Sorry, negative 4. Okay, now step 3, we're going to solve. And remember, when solving inequalities, you're going to flip the inequality if divide by a negative number. If you never divide by a negative, your inequality stays the same. But if you divide by a negative, it's going to flip around. So in order to solve, first I'm going to minus 3 from both sides. So I have negative 2x is greater than negative 7. Divide by negative 2. I've just divided by a negative number, so my inequality is going to flip around. X is less than 7/2. Okay. Next example, I have a fraction again, but I still need same base. So step 1, same base. I know that I can change 243 into 3 to the 5th power, but I have 1 over 3 to the 5th power, so I need to make it a negative 5 so I don't have the fraction anymore. So I have 3 to the 4 minus 3x power is greater than 3 to the negative 5th power. All right, now we're going to set our exponents not equal to each other, but greater than, because that's what was written. So I have 4 minus 3x greater than negative 5. Last, we're going to solve. And remember, you're going to look out for dividing by negative. If I don't divide by a negative, everything stays the same. So let's just solve. So minus the 4, negative 3x is greater than negative 9. Divide by negative 3. All right, I've divided by a negative, so my inequality flips around. X is less than 3. If I divided by a positive 3 there, nothing would change. But because I'm dividing by a negative, it's going to change around. And that's it.